For Lesson 5.3, you will be looking at complex fractions and unit rates. You will be able to simplify complex fractions and also find unit rates. Remember, the essential question for Chapter 5 is, how can you identify and represent proportional relationships? In the middle of the page on 194, you have the definition of a complex fraction. Fractions like 1/3, 1/2 are complex fractions, and they are simply fractions with one or more fractions in the numerator, denominator, or both. You have an Edpuzzle on complex fractions that takes it a lot further than what we're going to do out of the book, but it will stretch your thinking and how complex fractions can get even more complex. For the ones in the book, it's pretty straightforward as long as you remember how to divide fractions. Remember, when you're dividing fractions, you keep the first fraction and you do the reciprocal of the second fraction, and it becomes a multiplication problem. So the first step I'm going to suggest you take is to rewrite the fraction from this format to this format. And that will hopefully remind you to keep that first fraction and do the reciprocal of the second fraction and then do multiplication. So look through the example here given above, and then once you think you understand that, try to press pause and work out 1A, 1B, and 1C on your note sheet. Press play when you're ready to hear the answers. For 1A, you should have gotten 4/3, and if you reduce that to 1 1/3, that's fine. For 1B, you have 2/3 divided by 3/4, and when you do the reciprocal, you get 4/3, and then you can multiply straight across to get 8/9 for your answer on 1B. And for 1C, 1/5 divided by 6/7, 1/5 times 7/6, and you should get 7/30 for your final answer. Again, you can just write the answers down, but I would prefer that you write out at least this step to show that you understand how to divide fractions. This is kind of going back to Chapter 3 that we skipped over. We did do the pretest on it, but this is reiterating that concept of dividing fractions. On the next page, page 195, example 2, we are doing some more division with complex fractions. This time the denominator or the numerator is just a whole number and not a fraction. But we are going to continue doing it the same way by rewriting the fraction vertically to rewriting it horizontally, and then doing keep, change, flip. If you're ready to try 2A, B, and C on your note sheet, press pause and write out the problems, and then find the answer, and then press play to check your answers. For 2A, you should have gotten 2/21. For 2B, when you rewrite that, it's 2/4 times 1/2, and you can actually cancel out the 2's, so you get 1/4 for the answer on 2B. And on 2C, 14 is in the numerator, so we can make that into a fraction by putting it over 1, but it's not necessary. You can also cancel. 7 goes into 7 once, and 7 goes into 14 twice. 2 times 9 is 18. Now, if you didn't cancel, you would take 14 times 9 and then divide your answer by 7. You would still get 18 as an answer. But simplifying beforehand makes the problem a little bit easier. The next example is complex fractions with different units, and you can find the unit rate. And so if you look through the example 3, it walks you through step by step. Josiah can jog 1 1/3 miles in 1/4 of an hour, and you can find that average speed by dividing that out to find the unit rate. You can look through that example, and when you're ready, jot down the problems for 3A and 3B. Notice that I wrote that vertically first, and then I changed it to horizontal, and then I changed both fractions to improper fractions so that I could divide them out. You can press pause and try to work those out by yourself, and then press play when you're ready to check the answer. For 3A, when you change 4 1/2 to improper, you get 9 halves. When you change 1 1/2 to improper, you get 3 halves, but then you do the reciprocal, so you have 9 halves times 2/3. You can do some canceling here with the 2's and also the 3 and the 9. Your final answer should be 3. You get the same answer if you would have just multiplied 9 times 2, which is 18, and 2 times 3, which is 6. 18 divided by 6 is 3. And so the speed of the truck in miles per hour is 3 miles per hour. Actually, that was for 3B. Aubrey can walk 4 1/2 miles in 1 1/2 hours, so her speed is 3 miles per hour. The truck in 4A is written over here on the right side, 350 over 8 3/4, 350 divided by 35/4. When we do the reciprocal, we can cancel. 35 goes into 35 once, 35 goes into 350 10 times, and 10 times 4 is 40 miles per hour for the truck. And so just checking the answers here, 40 miles per hour for 3A and 3 miles per hour on 3B. The next example is on page 196, number example 4, got it? That's at the top of the page here. You can also use complex fractions to write percents as fractions. Notice the example here writes 33 1/3% as 33 1/3 over 100 because the word percent means per 100. And then we change that to an improper, and we change it to a multiplication of the reciprocal, and we get our answer as 1/3. Now, these can be done several different ways. If you have 33 1/3% memorized, then you know that the fraction is 1/3. But this strategy is useful if you don't have those memorized. For example, 4 1/2% is per 100, so that would be 9 over 2 times 1 over 100. Now remember, I am taking the reciprocal of 100, so I skipped a step and showed the reciprocal, and I changed it to multiplication. 9 times 1 is 9, and 2 times 100 is 200. For 4B, 12 1/2 over 100. Now you could do this other strategy, which is 12.5% if you write it out as a decimal, and you know to go from a percent to a decimal, we just move that back 2 places. And so 0.125 is my decimal, and I actually have that one memorized. It's 1/8, but you could just move that decimal back 2 places, and then 125 thousandths reduces to 1/8. There's lots of different methods to use in math, and not one method is the best. It just works in different situations for different types of problems. So knowing a couple of different strategies is always going to be helpful for you to decide what you want to use. On 4C, 10 2/3 over 100 would be 32 thirds times 1 over 100, and then we get 32 over 300, and we can simplify that to 8/75. And 33 1/3 is 10/3 times 1/100. And we can cancel out the 10 and the 100. And 1 times 1 is 1, and 3 times 10 is 30. So 1/30. Whether you're doing these problems by memorizing what the percent and fraction equivalent is, or you're using a complex fraction to figure it out, or whether you're writing it as a decimal, moving it back 2 places, and then simplifying, all of those are strategies for writing percents as fractions in simplest form. The next problem we will do is on page 198, number 38, and on that problem, it's asking us to find who is running faster, and so I've set up 2 complex fractions, one for Emma, which is running 3/4 of a mile in 6 minutes, and Joni running 1.5 mile in 11 minutes. That's 3/4 divided by 6, which is 3/4 times 1/6, and 1.5 divided by 11, which is 3/2 times 1/11. When we multiply, we get 3/24, which can be reduced to 1/8 and 3/22, and we can't reduce that. So once you've simplified, you can compare the two, and whose speed is greater? Joni's speed is greater. Emma's rate is 0.125. Again, they took that 1/8 there and changed it to a decimal, 0.125. And Joni's was 3/22. And so if you take 3 divided by 22 on a calculator, you get 0.13636 repeating. And so that one is greater. Hopefully these problems have helped you understand how to work with complex fractions. They're really not too complex once you get working on them, but the Edpuzzle does take it to the next level. So just stay focused and make sure you're ready for a little bit of a challenge, and I'm sure you'll do great. Let me know if you have any questions.